Okay, so the next topic is the categorical variables. So far we considered these three variables, right? The humidity, wind speed, and temperature, and this is what? This is a numerical variable, which is a continuous, right? So numerical variables. However, we do not that the bikes data set has more potential predictor variables that we consider incorporate into our model, and another one is like another the variable that we should consider is a season, holiday, weekday, and weather, right? So when you look at these four variables, season, holiday, weekday, and weather, they're using the summary functions to look at these four columns, right? And this is like bikes too. And you see that this season and holiday and weekdays and weather is definitely are categorical variables. So if you look at the season, it has how many? So it has 177 ones, right? So that means like winter, for example. And the two means spring and fall, and winter, spring, the summer, and for example, like what fall is being I think it's winter. So for example, yeah, one is a winter, and the two is a spring, and three is a summer, and the four is fall, right? So if you look at this data set, the bikes two, I think where is the bikes two? Yeah, so if you look at the bikes two, if you look at the season, right? The season has one, right? One means what? The one means winter, right? Winter, and two means spring, etc. So how many ones? There are 177. And the holidays, 0, I guess, is non-holiday. 1 means holiday. So it means there are 21 holidays, right? Weekdays is 6 means, how many 6? There's 96 of them. 6 means, let's see. Yeah, I think that the 0 means a Sunday, 1 is a Monday, Tuesday, and Wednesday, and Thursday. The 5 is Friday, and 6 is a Saturday, right? So this is, as you can see, so obviously these variables are what? These variables are categorical, right? It has the levels. And like if you look at the weather, 2 means what? The 2 means the light the precipitations, and 3 is a heavy precipitation, is a lot of rains, right? It's rainy days. So how many rainy days? There are 15 rainy days, right? Okay. So I guess this is like probably California. But anyway, okay, so that's the so the thing is you try to incorporate this into our model, this categorical, right? So that's the idea, and it is common actually, and it is common to incorporate both continuous like numerical variables and the categorical variables into the model. So it's common, right? So if we first do that, as like number does not make sense, and maybe it's better to perform additional transformation of this data, right? So using this function called reval along with the mutate. So the bikes 2 will be inputted into the function mutate, right? And then the season, the column season, the value of the column season will be changed. When you use the mutate function to the existing column, the value of that column is going to be changed, right? And equal to reval, they're using a revalue functions. So the column is a season, right? And then these are the vectors. So they provide, for the second argument, they're providing the list. So after you run this, right, your season column will consist of what? Winter, spring, summer, and fall, instead of like 1, 2, 3, 4, right? And this is something that is good to know, right? So the same thing for the holiday and weekdays and weather, right? So after you run this code, there will be no more ones. Instead, if you look at the weather column, it's going to be the clear, right, etc. So that's the idea. So now we're going to build a new model. It's called Bikes Model 4, and previously is Bikes Model 3, right? and they're using the LM, right? And then they're using the bikes2 as a data. And then the rental is a response variable, target variable, right? Dependent variable. There are many names. And then the humidity, wind speed, and etc. Right? Up to here is of same, right? But now they're gonna use add season, right? So the season, as you can see, what? It's a categorical variables, and we have just changed its value, right? So we added the season into this model, right? And then look at the result, right? And let's look at the result, and the result saying that it's kind of this is like interesting result, okay? Let me just delete this. Okay, so the interesting result is, I want you to take a look at this result. This is interesting. This is definitely worthwhile paying attention to, right? So yes, humidity. Oops. Let's see. Okay, there's a humidity and wind speed, temperature, and humidity 2, which is a polynomial predictor, and then temperature 2 is a polynomial predictor. Now, this is for the categorical variable because we just added what? We just added a season, right? And then yes, and some people may ask you, Professor, how come there's this many the categorical variables? We just add seasons, right? But that's the way it is, because if you look at the season, how many levels? There are 4 levels, right? There are 4 levels. What? The winter, spring, summer, and what? The fall, right? So it has the four levels, right? This is like a factor. In this case, the R, these LM functions, they create the dummy variables, right? They create dummy variables for each level, okay? So that's why you have a spring, and then you have a summer, and then you have a fall. Then how come there is no winter, right? Winter, there's no winter, right? There's a reason, okay? If you look at this, okay, you know what? For now, before we move to the next section, I just want you to know that it's, so if you look at the spring, right? Dummy variable spring, right? The spring is what? It's a significant, right? So this is good. And then if you look at the summer, it's a significant, right? Because, this is what? Anywhere between this, right? So it's less than 0.05, obviously. And then the fall, yes, is significant. It's going to impact the response variable, which is rentals, right? So this is good, right? And so now, but what about the winter, right? The winter is, there is none, and this season winter is called something called the baseline, okay? I assume that you already watched the video tutorial on the regressions, right? So you know that it's, you're already familiar with this idea, right? Hold on. Yeah, I assume that you already watched this video tutorial. This number 4 and 5, and especially the 5 one is categorical X variables and interaction terms, right? So I assume that you watched the number 5 video tutorial already. So now you probably have some idea about this dummy variable. But let me just explain this one more time in this lecture. Okay, so basically, for example, right, ith observation in our data set has a value spring, a season variable. So in our models, the value of the predictor variable is what? The season spring. For that observation will be 1, right? And will be 0 if both predictor season summer and season fall, right? So note that the season has 4 distinctive values, and our model has only 3 dummy variable, and this is there's no dummy variable for the season winter, and this is by design. In this example, the dummy variable season winter is known as what? Baseline, right? Okay, So that's the idea, right? So when you actually include the categorical in the model, this ln functions automatically create these dummy variables, right? In this case, it's 3, and I'll show you why. Okay, I'll show you why. Let's say, so this is like dummy variable, right? So in this case, we have what? Oops, hold on, it's not working. Okay, so it has 3 dummy variables, right? If you look at our model, and this is y. Okay, hold on. Okay, so if you look at the season, right? Seasons. This is what? This is the categorical variables. It has 4 levels, right? The winter, and then the spring, and then summer, right? And then what? The fall, right? It has a 4 level. So basically, if you draw these things, we have winter, spring, summer, and then fall, right? So when you look at the data, let's say ith observations, and when is this springtime, then it's gonna be, this value is gonna be 1, and the rest of them is gonna be 0, 0, 0, right? So let's say this is like in a 3rd observation, for example, ith observation. And then let's say if you look at the 4th observations, let's say 100th observation, right? It's a 100th observations. This is, by the way, this is just an example, right? So let's say if you have 100 observations, and then if that observation is a fall, then it's going to be 1, and then 0, and 0, and then 0, right? So basically, as you can see, maybe we'll shoot one more example for the summer, and then it's going to be 1, and then 0, and then 0, and then 0, okay? Okay, so if it's a winter, right? If it's a winter time, it's gonna be what? It's gonna be all 0, 0, 0, 0, right? So this indicates what? This indicates winter, right? And that's why we don't have to create another additional variables. And this is called, the baseline. This baseline, right? Is everything is what? Everything is a 0, right? If everything is 0, that means it's winter. So this is called baseline. And that's why, right? And that's why, as you can see, there are only 3 dummy variables, right? There's no dummy variable for the season winter because we don't need to. If everything is a 0, right? That's what? That's a winter, right? Everything is okay. So now the next thing that I want to discuss is unlike with the continuous variable, right? If you have a continuous variable, what happens? If you have a continuous variable, right? The degree of the change in the response variable as a result of the unit change, this is unit change in the value of the predictor, right? So that's for the continuous. However, for the coefficient of the categorical predictors, it's as the average difference in the change of the response variable between each predictor value and the baseline. So this is very important. So in our case, right? In our case, the coefficient of season spring, right, is the average difference in the number of the bikes rental between the spring and the baseline of winter, right? And then similarly, the coefficient for the season summer and the season fall are the average difference in the number of bikes rental between the summer and the winter and fall and winter. So the winter, right? The winter is what? Is a baseline, right? So in your interpretation, it should be slightly different compared to the continuous variable. So this is like what? Average difference in case of the spring, it's average difference between the bike rental between spring and the baseline, which is winter. Okay, that's how you should interpret the coefficient of this categorical predictors, right? Okay, so the result shows that if you run the result and it shows that there's some increase in the R squared value, adjusted R squared value, right? Compared to our previous model. So it's good to include the categorical variable, right? So this is like another way you can improve your model. Okay, in the next lecture, I'm going to show the implementation of this concept. Thank you. Bye.